Okay, we're going to take a look at a couple of definitions for our unit on, or our notes on converting fractions and decimals. We're going to take a look at the definition of a terminating decimal and some examples, and the definition of a repeating decimal and also some examples. So make sure the top of your notes says Unit 2-1, and we're going to talk about terminating decimals first. Let me give you some examples of terminating decimals before I give you the definition. And please, please copy these examples down. So terminating decimals are numbers like 2.5. It's a terminating decimal because there's nothing after the 5. There's no number that comes after the 5, so the number stops at the 5. Another example of a terminating decimal would be 5. So really the decimal point is right here, and there's nothing after the decimal point. That's a terminating decimal. -10, -10.6789 is a terminating decimal. That should be a decimal point because there's nothing after the 9. And one more example, 0.03 is a terminating decimal because, again, we don't have anything that shows us that there's a number coming after. This one stops at 5, this one also stops at 5, this one stops at 9, and this one stops at 3. So let's take a look at the definition of a terminating decimal. And a terminating decimal is any number that has a finite number of digits. And by finite, I mean we can count them. There's 2 here, there's 1 here. That means that the number stops or has an end. Sometimes that number will end at the decimal, and sometimes we'll have a few places after the decimal. The second definition we're going to take a look at is what's a repeating decimal, which is different from a terminating decimal. If I tell you, for example, to terminate your behavior, that means to stop. But if you continue to repeat it, that means you do the same thing over and over and over again. So let's take a look at a repeating decimal. So a repeating decimal is a decimal like 1.333. And these 3 dots at the end mean that that pattern goes on forever and ever. Another repeating decimal might be 2.676767 and ... So that means that this pattern of 676767, these 3 dots mean that the pattern is continuing, and the numbers that are repeating are 6 and 7. And finally, we'll take a look at 0.1212, and again, it's not a terminating decimal because these numbers down here continue to repeat. So if you remember what repeating decimal notation looks like from a few years ago, 1.3 we can write as 1.3, 1.3 with a bar over it. That bar means that the 3 repeats. 2.67 we can write as 2.67 with a bar over it. That means the 6-7 continues to repeat. And then 0.1212 we can write as 1212. So we only draw the bar over those digits that are repeating. So if we look at the definition of a repeating decimal is any decimal number that repeats the same patterns of numbers forever. And these little dots right here mean that that pattern is continuing forever, and there's usually 3 little dots. So now we're going to take a look at how do we take a fraction and turn it into a decimal, and then decide whether it's terminating or repeating. So we're going to look at the fraction 2/3. So I'll tell you what my daughter learned in elementary school. Her teacher told her that when you're writing a fraction as a division problem, this is the same thing as 2 divided by 3. And her teacher told her that the top dog goes in the house. So I'm going to put a decimal point and 2 zeros and put a 3 out here. So we're going to do this without a calculator. How many times does 3 go into 20? 3 goes into 20 6 times. Put our decimal point, put a 0 there. And 3 times 6 is 18. We subtract them. we get 20 again. 3 goes into 20 6 times. And if we continue that pattern, we would end up getting, continue to get sixes. So as a decimal, it's 0.66 with 3 dots. And we can also write that as 0.6 with a bar over it. So is this decimal terminating or repeating? These 3 dots right here and this bar tell me that this is a repeating decimal. So we're just going to write the word repeating in here. Let's go ahead and try the next example of 5/8. So again, 5/8 means 5 divided by 8. So once again, the top dog gets the house, and the 8 goes on the outside. So 0 and then our decimal point. How many times does 8 go into 50? 8 goes into 50 6 times. And 6 times 8 is 48. Subtract and we get 20. How many times does 8 go into 20? 8 goes into 20 2 times, and that's 16. Subtract and we get 40. And 8 goes into 40 5 times. And 8 times 5 is 40. And we are done. So as a decimal, 5/8 is equal to 0.625. We didn't have to continue to divide and continue to divide, so that means that this number and this fraction are a terminating decimal. The numbers stop. There's only 3 digits in the number, and it's 625, so this is a terminating. So let's take a look at our last example. Let me just erase these marks that I made right here so we can look at our last example. Oh, sorry, our third example is 7/9. So I'm going to show you a trick with the 7 in just a minute, or with the 9. So again, this means 7 divided by 9. So 7 goes inside, 9 goes on the outside, and we have 0 decimal point. 9 goes into 70 7 times. That's 63. Subtract and we get 70. 9 goes into 70 7 times. That's 63. And we get another 70. So hopefully you can see the pattern continuing, and we get 0.777, and we can write that as 0.7 with the bar, which means that number is repeating. So this would be a repeating decimal. So one trick with the 9s I'm going to show you real quick is if I have 1/9, that's 0.1111, goes on forever. If I have 2/9, that's 0.2222, goes on forever. 3/9, same thing, is equal to 0.333, and so forth, all the way up to 8/9. And we'll talk about this some more in class tomorrow. So again, let me just erase this right here so we have room to work. Okay, we're going to take a look at our last example on our notes page. 3 3/7. So when we go to write this, we're not going to have a decimal that starts with 0, we're going to have a decimal that's 3 point something. So the only thing we have to worry about dividing is the 3/7 over here. So I'm going to divide 7 into 3.00. 7 can't go into 3. 7 goes into 30 2 times. That's 14. Subtract it. No, it's not 2 times. Sorry. Goes in 4 times, and that's 28. subtract, and we get 20. Bring down the 0. 7 goes into 20 2 times. That's 14. Subtract, and we get 60. 7 goes into 60 8 times, and that's 56. And then we get 40. 7 goes into 40 5 times. And what's going to happen with this decimal is that we are going to get some repeating numbers. So 4285, you would have to keep on going on your paper, 71. And that same set of numbers will continue to repeat. So to write it as a repeater, 428571, the bar over the top, because it would continue to be 428571, 428571, 428571. So this one as well is a repeater. Okay, last thing on our notes page, we're going to take a look at these three fractions, 2/3, 5/8, 7/9, and 3 3/7, and we're going to put the fractions in ascending order. And so if we ascend the stairs, ascending means small to big. So what do you think descending means? Descending means big to small. So if we put these in ascending order, we have to look for we can't tell by the fractions because they're not all in the same language. So if we look at the decimal numbers, which of these decimals is smaller? 0.66, 0.625, 0.7, or 3.4875. And this one right here, 0.625, is the smallest. Then we would be, so we would write we would write 5/8. The next one, and think of money, if we have 62 cents or 66 cents, which one is smaller? 62 cents, then 66 cents, then 77 cents, then $3.42. And we'll write those with their fraction equivalents. So our first fraction would be 5/8, because that was our smallest decimal. Our next fraction is 2/3, then 7/9, then 3 3/7. So what we did is we took our numbers and we put them in order from smallest. Keep in mind that this one was 0.62, 0.66, 0.77, and 3.42. So from smallest to biggest, that's ascending order. Descending order, we're just going to write them backwards. So our largest number fraction is 3 3/7, then 7/9, then 2/3, and then 5/8. Okay, flip your paper over, and we will take a look at the back side. So let's go over the directions real quick. So without a calculator, classify the following numbers as terminating, repeating, or neither. And then simplify each number first if needed. So terminating stops, repeating has a pattern. If it doesn't stop and there's no pattern, let's write that up there. So if we have a number, for example, so the neither category would be a number, let's do an example of that, would be a number like 2.36794. There's no pattern in the numbers, so it doesn't stop because it goes on forever, and it doesn't repeat because there's no repeating pattern, so that would fall under the neither category. So let's do a few of these together. Let's take a look at negative 2/3. It doesn't matter whether it's negative or positive. We just worry about the fraction. So 2/3 we did on the other side of our paper, and we said that that was 0.6 repeating, and since it's negative, we're going to put the negative here. So this would be a repeating decimal. Because that's 6, it's 0.6666, keep on going, that 6 continues to repeat. Let's take a look at 5 times the square root of 2, and I'll give you a hint, and we'll talk about this again in class tomorrow. 2 is on our list of it's not a perfect square, so if it's not a perfect square, it's neither going to be terminating or repeating. It's going to be a number that goes on forever and ever and ever and does not repeat. So if we were to do 5 times the square root of 2, again, if we were to do 5 times the square root of 2, the square root of 2 goes on forever and ever with no pattern. So because this number here is not a perfect square, this is going to fall under the neither category because it won't have a repeating pattern and it won't have a terminating pattern. Let's take a look at the number 12. So the number 12, it's already simplified for us. Are there any numbers? Do the numbers stop? And if the numbers stop, then it's a terminating decimal. So the numbers stop. There's a 1 and a 2. We don't see any dots. So this would be a terminating decimal. And so this one, if we look at terminating, terminating means that it stops at some point. Okay, let's take a look at the example 8,700. Again, does it stop? And the answer is yes. So it is terminating. We don't see any dots, and we don't see any bars over any of the numbers. Okay, let's take a look at one more, and then I'll have you try the rest on your own. So we're going to take a look at the negative 4.31572 ... These 3 dots mean that it goes on forever, but we don't see a pattern in the numbers. None of the numbers are repeating in the same pattern. So then this one, it's not terminating, it's not repeating, it would fall under the neither category. So one thing I do want to note, and maybe we can put that up here with our neither category, if it falls in the neither category right here, that's usually the square root of non-perfect squares, like the square root of 12 or the square root of 32. They don't fall on our list of perfect squares, so therefore they're not terminating, they're not repeating, they would fall under the neither category. Okay, so for homework tonight, go ahead and try the rest of the examples on the back page, and we will go over those examples in class tomorrow. So you're trying all of these examples. Remember, simplify the square root of 4 first. Change 1/10 to a decimal. Can you simplify the square root of 48? Is 48 a perfect square? If the answer is no, then it falls under the neither category. Okay, if you have any questions, just jot them down.